The recent approval of another obesity drug, Zepbound, expands the options for medications to manage weight, but it comes with the same cost and access challenges that plague other weight loss drugs in its class. The drugs in this class are agonists, or mimics, of natural gut hormones that affect the body's metabolism and hunger signals in the brain. But the currently approved drugs, synthetic versions of these hormones, are large molecules that are expensive and time-consuming to manufacture, which has meant high prices for consumers and growing drug shortages. Further, most of these drugs are injections, rather than oral pills, and usually require refrigeration for storage. With more than 4 in 10 Americans, and nearly 2 billion people worldwide, affected by obesity, the promise of these new drugs to treat the world's fastest-growing chronic disease has been clashing with the reality of their cost and access problems. In addition to the complex manufacturing, the small number of obesity drugs on the market has meant less competition, driving up prices for consumers. That's a problem, as many private health insurance plans still do not cover obesity medications. Although researchers are developing oral versions of these medications, including versions that are cheaper and faster to make and distribute, those aren't yet ready for review by the U.S. Food and Drug Administration, and the existing oral medications aren't as effective as the injections. The big issue is the fact that right now, not only are the drugs expensive, but it's also difficult to get injections to places where people may need them. Ollie Zentner, a weight management physician and medical director of Revolution Medical Clinic in Vancouver, Canada, says. And in the United States, for example, equity depends on your income and your insurance. It doesn't really matter where you are. However, a half dozen or so candidates in this same drug class have been making their way through clinical trials, and as several of them are on track to head to the FDA in the next few years, experts hope they will finally begin expanding access so the world can begin making progress on addressing the obesity epidemic. One drug in development that has been turning heads is orforglipron, a drug like the already approved agonist drugs, but which is a smaller molecule, making it easier and cheaper to produce. It's also an oral pill, not an injection, which is not as sensitive to storage temperature as injectable medications are. Though only just entering phase 3 studies, the effectiveness seen from orforglipron in a phase 2 trial suggests that a more accessible option is not out of reach. Existing medications are in a form that we can use easily, but we can't make an injectable all that easily, says Sean Wharton, an adjunct professor at McMaster University and medical director of the Wharton Medical Clinic who is leading the research on orforglipron. To have something that you have to take every week for the billions of people across the planet that are living with obesity means that you need a product that can get there, that can be mass-produced, and then given out in an appropriate fashion. A confusing collection of weight loss drugs. The rapid pace of approvals for this new drug class has led to a dizzying list of names that can be difficult to track. A major reason for the confusion is that the FDA approves the same chemical drug for different conditions, and companies give different brand names to the drug based on the condition it treats. Many people have heard of Ozempic, the brand name for semaglutide, which is approved for type 2 diabetes. That same compound, semaglutide, is also approved to treat obesity and goes by the brand name Wegovy. Another major drug in this class is tirzepatide, which is approved for type 2 diabetes as Mounjaro, and for obesity as Zepbound. Zepbound's approval last month came after clinical trials showed people with obesity lost up to 21% of their body weight with the highest dose. With the pace of these approvals matched only by demand for them, what hasn't kept up is access to these medications, primarily due to drug shortages and their cost. Shortages of Mounjaro, which costs $1,023 per month without insurance, are already expected to last through August 2024. Its competitor, Ozempic, costs $936 and is also limited. Those supply issues are expected to carry over to Zepbound, same compound as Mounjaro, and Wegovy, same compound as Ozempic, and are similarly expensive. Zepbound's price is $1,060, Wegovy's $1,349. Ozempic was not the first of this new class of drugs to hit the market, but it was the first to become a household name as celebrities shared their weight loss success from its off-label use on social media. It was also the most effective drug of its kind when it was approved as Wegovy for obesity in 2021. But all of these drugs, called GLP-1 agonists, are injectable medications that mimic the effects of glucagon-like peptide, 1 GLP-1, a gut hormone that stimulates the release of insulin. And over the near decade since the first GLP-1 agonist was approved for obesity in 2014, scientists have learned enough to begin expanding their research to include other gut hormones. This is new science, and this is coming from someone who has been in this field for over 40 years, says Robert Kushner, an endocrinologist at Northwestern University's Feinberg School of Medicine in Chicago, who consults for some of the companies developing these drugs. As we start to harness the power of these intestinal and pancreatic hormones individually and as combinations, we are really learning along the way. While these new drugs definitely have side effects, some of which can be serious, they are biologically completely distinct from the less-than-stellar legacy of past weight loss drugs. We're now, for the first time, understanding that, in part, the gateway to regulating appetite and treating the dysregulation of appetite is through these gut hormones, Kushner adds. Zepbound is the first obesity drug to exploit more than one gut hormone. It mimics both GLP-1 and glucose-dependent insulinotropic polypeptide, GIP, another hormone involved in metabolism that plays a role in obesity. But GLP-1 and GIP are just two of the dozens of gut hormones that affect digestion and other metabolic processes. As scientists learn more about the functions of other gut hormones, they are testing drugs that mimic those as well. Many of the newer drugs coming down the pipeline mimic 2 or 3 gut hormones, such as GLP-1, GIP, and glucagon. It often happens in medicine that 1 or 2 agents of a certain drug class are development, and then the class opens up more, Zentner says. We are on the precipice, now that researchers understand the biology of these various hormones, she says. We've cracked the code of GLP, GIP, glucagon, and other gut hormones, so now scientists are testing what happens when they combine multiple synthetic versions in one drug. How the new drugs work. These drugs work in multiple ways that affect metabolism and energy consumption and expenditure. By stimulating the release of insulin after eating, they help reduce glucose circulating in the blood and reduce insulin resistance. They also slow down digestion and the emptying of the stomach so that people feel full longer. They stimulate the burning of fat cells and reduce fat in the liver. Finally, importantly, they also send satiety signals to the brain, telling it not only that it doesn't need additional calories but also that it doesn't want additional calories. I think of obesity as a multifactorial disorder where genetics, environment, development, and behavior play a role in a person's likelihood of having the disease, but the most important organ regulating the weight is the brain, says Fatima Cody Stanford, an associate professor of medicine and obesity medicine specialist for adults and children at Harvard Medical School. That's because the brain is very efficient at hunting for and storing food, essential functions in times of scarcity. When we talk about appetite regulation or energy regulation, we evolved to endure famine, Zentner says. But many people today live among an abundance of food, and the brain's evolution hasn't kept up. The beauty of these new medicines is that they block the inappropriate starvation response that causes obesity, Zentner says. For patients with obesity, even when they eat, their brain still thinks they're starving. With these new drugs, however, not only do people not feel hungry, but they just don't have the craving or food thoughts they used to because their brains are not starving. The problem is that they aren't easy or cheap to manufacture. But clinical trial findings from Wharton's drug, orforglipron, and other research findings, unveiled at the annual meetings of the American Diabetes Association, ADA, last summer, and at the Obesity Society meeting last fall, suggest that researchers are finding ways to overcome those obstacles. What we saw at ADA was a further introduction of the injectable molecules, where you're getting weight loss of more than 25%. That's huge, Wharton says. But these injectable drugs risk continued supply problems. If we develop a pill that's easily stored that you can take every day, that may be the most available drug that's cheap. Better, cheaper drugs in the pipeline. The upcoming crop of drugs in the pipeline attempt to improve on existing ones in 3 ways. Many act on multiple gut hormones for a synergistic therapeutic effect. A couple are pills, which have wider temperature ranges for storage, making them accessible in places with less reliable refrigeration. Finally, some of the oral drugs in development, like Wharton's, are made of smaller molecules that are easier and faster to manufacture, making them cheaper and less likely to fall victim to the shortages occurring with semaglutide and tirzepatide. The main gut hormones being mimicked and combined in different medications are GLP-1, GIP, glucagon, and amylin, another hormone released by the pancreas which regulates blood glucose levels, slows down digestion, and reduces food consumption. Novo Nordisk, the company that makes Ozempic/Wegovy, is working on a drug combination of semaglutide and cagrilintide, which mimics amylin. In a phase 2 trial of the drug, dubbed CagriSema, participants with type 2 diabetes experienced reduced blood sugar and a 16% loss in body weight. 2 other drugs from other pharmaceutical companies mimic GLP-1 and glucagon, a hormone with receptors in the liver. One of these is survodutide, whose phase 2 trial resulted in participants losing 15 to 20% of their body weight, depending on dose. That trial is ongoing, so participants could still lose more. The other GLP-1 and glucagon combo drug is pemvidutide, being tested for both obesity and fatty liver disease. In the most recent results from late November, participants lost 10 to 20% of their body weight, and nearly a third of those taking the highest dose lost 20% or more. Side effects. Like semaglutide and tirzepatide, however, all these drugs come with gastrointestinal side effects, nausea, vomiting, and diarrhea. 1 in 4 people taking pemvidutide, for example, dropped out because these side effects were too intense. The drug furthest along of those that attempt to mimic 3 gut hormones is retatrutide from Eli Lilly, the same company that makes Mounjaro/Zepbound. Retatrutide mimics glucagon, GLP-1, and GIP in combination. Participants taking the highest dose lost about 24% of their body weight, the most of any weight loss drug so far, and rivaling the effects of some bariatric surgery types. For example, after 1 year, average weight loss is 25% of body weight for sleeve gastrectomy, and an average 14% of body weight for adjustable gastric banding. Retatrutide also reduced liver fat, so it may be a contender for treating fatty liver disease too. One of the oral pills showing the most effectiveness for obesity is an oral version of semaglutide from Novo Nordisk that's a higher dose than their current Rybelsus. It showed a 15% loss in body weight at the ADA meeting in June, but the company hasn't submitted it to the FDA for approval yet. Focus on oral drugs. Meanwhile, participants taking orforglipron, the drug Wharton's team is developing, in a phase 2 trial lost 15% of their body weight, about middle of the pack compared to other drugs. But again, it is a small molecule that can be made and transported cheaply and easily. The more we learn about the disease, we learn it's not a one-size-fits-all thought process. Asthma is not the same in every person. Diabetes is not the same in every person. Cancer is not the same in every person. But these medications, she says, are the newest tools doctors can employ in addressing obesity as a disease.